Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we want to tell whether the triangle is a right triangle. So, I noticed that these two angles are definitely acute. This angle looks like it could be a right angle, but we don't know for sure. That's what we're trying to figure out. So, the side opposite the right angle, I put it in quotes because we don't know if there's a right angle or not, but that's C. And then the other two sides are A and B. So our question is, does A squared plus B squared equal C squared? Let's see. We have 22 squared plus 14 squared. Does that equal 26 squared? Let's see. 22 squared. Oh my. I clicked the wrong thing. 22 squared is 484. Plus 14 squared is 196. And 26 squared is 676. Okay, 484 plus 196 is 680. Oh, 680 is not equal to 676. So, we don't even need these question marks anymore. We can erase them and we can say no. A squared plus B squared is not equal to C squared. So this is not a right triangle. Not a right triangle, because A squared plus B squared has to equal C squared in order for this to be a right triangle. Okay, cool. Nice review from the last video. Now let's jump in to what we have for today. Today, we start our work on section 9.2, special right triangles. These are actually very important. We're going to use these in geometry. You are going to use these in advanced algebra trig. You are going to use these in pre-calculus if you choose to move on to pre-calculus. So, we're going to pay extra special attention. Okay. I'm funny. So, there are two different special right triangles that we're going to look at. In this video, we are going to look at the 45 degrees, 90 degrees triangle. And in the next video, we're going to look at the 30 degrees, 60 degrees, 90 degrees triangle. And typically we just shorten this to 45, 45, 90, instead of saying the word degrees over and over again. So, our learning target is that you know what is a 45, 45, 90 triangle, and what properties does it have? What's so special about this particular right triangle? So that's what we're aiming to learn in this video. How will we know if we have learned that? Well, you'll be able to use the properties of 45, 45, 90 triangles to find side lengths. So you need to be able to find side lengths using the properties of 45, 45, 90 triangles. So, again, we're going to talk about what a hypotenuse is. The hypotenuse is the side opposite the right angle of a triangle. That is still important, and remember the other two sides are called legs. We're going to use this terminology today, so I want to make sure that you remember it. Now, we're going to do something a little bit different than we typically do in these YouTube videos. We're going to do an exploration. I don't want to just tell you what the properties of a 45, 45, 90 triangle are. I want you to experience them and discover them and see where these properties come from. So, where does a 45, 45, 90 triangle come from? Well, we're going to take a square. So this is a square, and remember, a square is a rhombus, which means that all the sides are congruent, And a square is also a rectangle, which means that all of the angles are 90-degree angles. Now, because we are cutting this square in half along the diagonal, so we just decided we want to cut it in half. So let's draw this line down the middle, along the diagonal. Now, remember from section 7.4, and actually the video was part 1 of section 7.4, the rhombus diagonals theorem says that the diagonal of a rhombus bisects the angles. So if this is a 90-degree angle in the corner and we bisect the angle, we are cutting 90 degrees in half. What is 90 divided by 2? The soccer fans will know that this is 45. Because 2 halves, right? Each half of a soccer game is 45 minutes, so the game is 90 minutes in total. So, this is where we get our 45, 90 triangle. This is why it's called a 45, 45, 90 triangle, is because one angle is 45 degrees, another angle is 45 degrees, and the third angle is 90 degrees. So that's where 45, 45, 90 comes from. So we still have the right angle down in the corner because this is half of a square, and then we have two 45-degree angles because the diagonal bisected our corner angle in half. Now, we still have that these legs are congruent. Because this came from a square, we still have these tick marks, and we still have this right angle box. The only new thing we did from this square is we took out this triangle, and we noticed that, the angles that were bisected are 45 degrees. So that's what we've done. And this is where our 45, 45, 90 triangle comes from. So, now, we're gonna do a little bit of review. Now what we've done isn't super new. So, the 45, 45, 90 triangle comes from a square, which means that the legs are congruent, right? We still have these tick marks here. Now, suppose that one of the legs is 8 units long. We'll just say we had a square and all of the sides were 8. So when we cut this triangle out of the square, the sides of the square are 8 units long. We're just pulling that number out. We can use any number you want. And if we were in class right now, I would say, what number do you want to use? Do you want to use 4? Do you want to use 6? Do you want to use 3.5? What do you want to use? For this video, I picked 8. Because it's my little sister's favorite number. Okay. Now, what we're going to do, we know that both of the legs are congruent. This came from a square, so both of the legs are congruent. But what is the length of the hypotenuse? The hypotenuse is the side opposite the right angle. How long is it? Is it 9? Is it 10? Is it 4.1? Obviously it's bigger than 8 because the hypotenuse is the longest side. Is it 8.1? Like what is it? Well, we can figure out what it is using the Pythagorean theorem. So that's why I say a little review, because we're going to use the Pythagorean theorem. So we have the legs are A and B. So we have 8 squared plus 8 squared equals c squared, whatever the hypotenuse is. So we have 64 plus 64 equals c squared. 64 plus 64 is 128 equals c squared. And then we're going to take the square root of both sides. So c is equal to the square root of 128. Now, we could get a decimal And that would be helpful if this were like a word problem and I wanted to know, like, well, what is the square root of 128? Like, what does that look like? If I told you that this pencil was 128, was the square root of 128 centimeters long, what does that mean? What does that mean? How long is that? In this problem, we want to keep an exact answer. An exact answer. So we need to simplify this radical. And we talked about simplifying radicals in part 1 of section 9.1. There's also another video about simplifying radicals. Videos all about simplifying radicals. I will put that in the description. But what we need to do is we need to figure out what square goes into 128. So remember we have 3 squared is 9, 2 squared is 4, 4 squared is 16, all the way up to like 12 squared is 144. Of course there are more, you can do 13 squared and all that. But typically, for this class, you won't need anything bigger than 12 squared for simplifying radicals. Typically. Alright, so, let's try 5 squared. You want to start with the bigger ones first, because if we start with a smaller one, I might be able to divide by 4 like multiple times. And then that gets confusing. So let's start with a big one. Let's start with 25. 128 divided by 25, gives us a decimal. 128 divided by 36 gives us a decimal. 128 divided by 49 is a decimal. 128 divided by 64. 128 divided by 64 is 2. Awesome. So see, if we had divided by 16, we would have gotten 8. But then wait, 8 is divisible by 4, so like, it gets tricky. You want to divide by the biggest number possible. There's also another way you can make the tree. You can make the factor tree if you want to. There's more about that in the simplifying radicals. Watch the video. There's a link in the description to a simplifying radicals video. You can learn about the factor trees if you want to. But 128 divided by 64 is 2. That means that the square root of 128 is the same thing as 64 times 2, which is the square root of 64 times the square root of 2, which, hey, the square root of 64, that's 8. So we get 8 times the square root of 2. So C is 8 times the square root of 2. Hey! 8 is the same number as the leg! Is that a coincidence? Does this happen every time I have a 45, 45, 90 triangle? What do you think? What do you think? And if you wanted to test and see for yourself, try a different side length. Try, instead of 8, use 3. And try it for yourself. Pause the video right now. Try it for yourself and see, do we get 3 times the square root of 2? Is that a relationship that works? Try it for yourself. See what happens. Unpause the video and we're going to talk about the next slide, which has a 45, 45, 90 triangle theorem, which says that in a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. So, if you know what one leg is, you know what the other leg is, right? The legs are congruent. The legs are congruent in a 45, 45, 90 triangle. So if you know what one of the legs is, you just need to multiply by the square root of 2, and that will give you the hypotenuse. Now, you can also be given the hypotenuse. and have to find the leg. In which case, you would do the opposite of multiply by the square root of 2. You would divide by the square root of 2. And we're going to see examples of both of these, multiply and divide, in the next slide. Find the value of x and write your answer in simplest form. In simplest form, so that means that we want to simplify any radicals that we might get. So, let's do part A first. We'll notice that we have a 90-degree angle and one 45-degree angle. Uh-oh, I don't know what this angle is, though. Wait a minute. Yes, I do. There's 180 degrees inside of every triangle. So if I have a 90-degree angle and a 45-degree angle, this other angle has to be 45 degrees. Because those are the only numbers that are going to add up to 180, if two of them are 90 and 45 degrees. Okay. That means that I have a 45, 45, 90 triangle, which means that the legs are congruent, so this side is also 8. Now, what is the length of the hypotenuse? Well, this is actually the exact example that we did in our exploration. In order to find the hypotenuse, I just need to multiply by the square root of 2. The hypotenuse is equal to 8 times the square root of 2. Ta-da! The end. Remember that in Big Ideas, if you do your homework in Big Ideas, which my students do, you will want to type the answer into Big Ideas exactly like this. No decimals. Don't figure out what the decimal form is. We want exact answers. No decimals. All right, next, part B. We have 5 times the square root of 2 is the hypotenuse. It's opposite the 90-degree angle. So 5 times the square root of 2 is the hypotenuse. And I know that the legs are congruent, so this tells me that this is a 45, 45, 90 triangle because the legs are congruent. So this is a 45, 45, 90 triangle, and I know that the hypotenuse is 5 times the square root of 2. Well, we know the pattern. The legs are one number, and the hypotenuse is just the square root of 2 times that number. So, in order to get my legs, I need to divide by the square root of 2. Because I have the hypotenuse and I'm trying to find the leg. If I have the leg, I multiply by the square root of 2 to find the hypotenuse. If I'm going the other way, if I have the hypotenuse but I'm trying to find the leg, I'm going to do the opposite of multiply by the square root of 2, which is divide by the square root of 2. So 5 times the square root of 2 divided by the square root of 2. You can think of this as 5 times the square root of 2 divided by the square root of 2. Square root of 2 just cancels out and we get 5. So x equals 5. There you go. Let's see if we were correct. Hypotenuse equals the leg times the square root of 2. So x is 8 times the square root of 2. Hypotenuse is equal to the leg times the square root of 2, which means that we need to divide by the square root of 2, and we get that x is equal to 5. Ta-da! Now, it's worth noting that on your homework, you might get trickier answers than this. They gave us 5 times the square root of 2. So dividing by the square root of 2 was easy, because the square root of 2 just canceled out. If they had given us just 5, then we would have had to do 5 divided by the square root of 2. And that would have been our answer. So, make sure that you're paying very close attention. Don't just say, oh, it's 5, that means I should add a square root of 2 on the end. Not necessarily. If you have the hypotenuse, you need to divide by the square root of 2. If you have a leg, you need to multiply by the square root of 2. All right. That is our only example for today. I wanted to make sure that we took enough time to really explore where this triangle comes from. When I learned about these triangles, it was kind of just, here's the triangle, multiply by the square root of 2. And I was like, okay, I guess. But really understanding where the triangles came from was very helpful to me when I became a teacher and started teaching this myself. So, now is a great time to assess your understanding of the learning target and the success criteria. Do you know what a 45-45-90 triangle is? Do you know where it comes from? Do you know when to multiply by the square root of 2 and when to divide by the square root of 2? If so, you are good. You are a 3, and you are good to finish your homework, help your friends, help your classmates. If you are like, I understood a lot of what you said in this video, but I don't know about all of it, that's okay. You're a 2 and you should start the homework, and if you get stuck, ask for help. And if you are totally lost, you're very confused by 45-45-90, square root of 2, what? That's okay. That would be a great time. If you're a 1, that's a great place to ask questions and see where you are stuck in your learning. And it's okay to be stuck. We are all stuck sometimes. So, here are some practice problems you can do to practice the skills that you have learned in this video. There's only 4 of them, because we only did 1 example. So, try those, see, these will help in assessing your understanding of the learning target and the success criteria. And as usual, let's end our video with a launch. This launch comes from Oscar Wilde, and he says, "You can never be overdressed or overeducated." So people can sometimes say, oh, you're overdressed for this occasion, like you dressed up too much. And then, I don't know, people could say you're overeducated, you're too educated, you don't need a PhD to do this or something. But you can never be overdressed or overeducated. If somebody says like, wow, you're too dressed up, like, I just felt like being a little extra today. Nothing wrong with being a little extra every once in a while. You can never be overdressed or overeducated. Somebody's like, man, you too smart. No such thing as too smart. You can never be too smart. So keep learning. Be extra. In outside of school, in the way that you dress, in the way that you talk, be extra. And in the way that you do your homework, and the way that you participate in class, be extra. Answer the questions the teacher asks. Ask your own questions. Help your classmates. Like, be extra. Nothing wrong with being extra, whether it's in the way that you dress or in your studies in the classroom. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.